So the earth is different. Very obviously it's different from everything we've looked at. And the question is why? So we looked at Mars, supposedly the most Earth-like of all the planets. We've looked at Mars for 38 years. There have been 2 flybys, 8 orbiters, 2 Viking landers, 4 rovers. We have a combination of 17, well now almost 20 years on the surface of Mars. We've explored more than 48, 50, 60 kilometers by now of the surface in various places. And the result is that there has been not a single blade of grass found, not a single microbe, not a single fossil microbe. There has been no sign of life anywhere so far. They may find it tomorrow, but in 38 years we've found absolutely nothing. And it's not because of lack of effort. So the earth is very different. And the question is, why? I want to start out by looking at what Genesis says about the earth. In verse 2, okay? Now the earth was formless and empty. Darkness was over the surface of the deep, and the Spirit of God was hovering over the waters. And the question I have is, what was the Spirit of God doing while it was hovering over the waters? And what was the result? Well, if we look at it, we see that God said, let an expanse be an expanse, and He called the expanse sky. And we see a sky on earth that's unlike anything else in the solar system. No other planet has clouds of water vapor. No other planet has an oxygen-rich atmosphere. No other planet has what Earth has. And He said, let the water under the sky be gathered in one place, and the dry ground appear. And we have continents, and we have Africa, and the Middle East is shown here. We have temperate oceans. You don't find those anywhere else. Then He says, let the land produce vegetation. We have all kinds of plants. Let the birds fly across the expanse of the sky. We have birds. And we have fish in the sea. And we have critters. And then He said, let us make man in our image. And He added to man, be fruitful and increase in number, fill the earth and subdue it. And I would submit to you that that is the only command God has ever given to mankind that mankind took seriously. So, what I want to look at today is not the fact that earth is, too far, back, there. No. We're bouncing. No, not there yet. Back one more. Forward one. We'll get synced up. Nope, you went back. Okay, we must have do we have the same?
We need one slide.
Okay. So, earth is different, and the question is not the fact that it is different. Anybody can see that. The question is, how is it different, and why is it different? So the first thing I want to look at is the special location of Earth. I don't know if you've ever thought about it, but we're all here tonight because Earth is in a very special place. It was placed there. If we go back and think about the galaxy we talked about yesterday, this is a galaxy similar to our Milky Way galaxy. And if we look at the center here, blow it up and look at the center. Okay? There it is. The center is a very violent place. Very dense crush of stars. And other things, clouds. The gravitational fields are extremely strong. It would be almost impossible for a planet like ours to survive there. It would be literally ripped apart. We would have incredible levels of radiation, not just heat and light, but gamma rays and X-rays and all kinds of bad stuff. But that's not where we are. It just so happens that in the Milky Way, we are 3,000 light years from the center. You remember a light year is about 6 trillion miles, that's 9 point something trillion kilometers, 1 light year. We're 30,000 light years from the center. So we're out here, not in the center where all the activity, but out here in the suburbs where there's not much going on. And not only that, we're not in one of these arms, we're in between two of the arms. Now, if we were in the center, all we would see around us is other stars and clouds. We wouldn't see anything. We wouldn't have a night sky. If we were out here in one of these arms, we would see clouds everywhere. But we've been put between the two of those, and as you'll see, that gives us the ability to see the universe. Yesterday I introduced you to the giant star Antares. Antares is so huge that if you put it where our sun is, it would engulf the first 4 planets of our solar system: Mercury, Venus, Earth, and Mars. It's huge. But we don't have that star. We have our sun. Our sun is much smaller than Antares, and it's a good thing. But our sun is different in other ways. For example, if you look at it, it's still large, 109 times the diameter of Earth. Its mass is 143,000 times the mass of Earth. But the important thing is it gives out the right kind of radiation. A lot of stars emit radiation that is deadly. Our sun emits mostly visible light. The visible light spectrum of our sun puts out is 500,000 times the intensity of its X-rays. Other stars put out mostly X-rays. And the other thing, last thing, it's very stable. It's not a young star. It's not like a teenager jumping all over the place and doing various things. It's a middle-aged star that doesn't get excited, doesn't change much, just very stable. And that's very, very important. So let's go back and look at our solar system, and you see the orbit of Earth here in gold. And you remember in our tour, we found that Mercury and Venus were very, very hot. Far too hot for life. Mars was cold. It turns out that around any star, there would be a certain distance from the star where a planet orbiting in that particular favored position could, in theory, have liquid water on its surface. And that turns out to be exactly where Earth is. If we look at the characteristics of this orbit that Earth is in, this gray area here is the band of orbits that a planet anywhere in that band could have, not necessarily would have, but could have water on its surface. Notice that we are close to the inner limit of that band. So that means that if we moved a little closer, our oceans would evaporate eventually. In fact, if the sun brightened at just 10% and stayed there, it would eventually heat the Earth up enough that we would lose our water on the surface. Okay, this is a solar eclipse. It's interesting, there's some 170 or 80 moons in our solar system around other planets. We have only one. But in order for there to be a solar eclipse, it takes a special alignment of the sun, the moon, and the planet. same size as the sun. So it has to, turns out that our moon is a half a degree in angle if you look at it, and so is the sun, half a degree. And that's because the moon is exactly the right distance from Earth to make it appear to be the same size of the sun, which is 4 times bigger. This is 400 times bigger, 400 times closer. So it's a very special relationship required to have a solar eclipse. This is the only place in the solar system that you can see a solar eclipse. And what we know from the solar eclipse is, go back one, it shows the sun's halo. And because of this, we're able to determine what makes the sun operate. It's a special type of nuclear reaction. And if we couldn't see this, we wouldn't know that. So it's almost like we've been placed in the stadium at the 50-yard line where we can see the game very well. We're placed in around our galaxy where we can see space, and we're around our sun where we can, and the moon where we can see the sun. There are other things about the Earth that allow it to be like it is, and it has a number of protective shields, and I want to look at those. I want to start by looking at the moon. This is the surface of the moon. You see an astronaut there. The astronaut has on a suit that weighs about 300 pounds. What's that in kilos? About 150 kilos. Because he has to have oxygen supplied. The side where the sun's shining gets very hot. The side where it's not gets very cold. So he has an air conditioning system. Otherwise he would cook or freeze. There's no atmosphere there, obviously, so he has to have an atmosphere, and it has to be pressurized. You notice the moon has no atmosphere and no water. But the moon is orbiting around the Earth. And the Earth is in that favored orbit around the sun, remember? The Goldilocks zone where it's just the right distance to have water. So why is it that the moon doesn't have water or an atmosphere? Well, it turns out, I'm sorry, okay. It turns out that having an atmosphere is important in a number of ways. And I'll come to the answer in a minute. Because this moon has no atmosphere, it has no protection. And you see what happens. There's meteors hit the moon with tremendous force and do tremendous damage. We'll look at this peak here. There's a peak. There's see the little rock, the boulder there, and we'll go up there. And when we get to the close-up, you see this looks like an ash heap. Not a very pleasant place to look at or to be. Radiation from the sun, other stars, meteors, all kinds of things going on. It's not a very nice place. Why is it that the moon has no atmosphere to protect it? And it has no water? Well, it has to do with size. It turns out that a planet, in order to have water, doesn't only have to be the right distance from the sun, but it has to have enough gravity to hold water and atmosphere to its surface. The moon is too small. It's about 1/4 the size of Earth. Has 1/6 the amount of gravity. So if the moon ever did have any atmosphere of water, it simply evaporated and went out into space. Couldn't hold it in. Earth turns out to be the right size to hold its atmosphere and its water oceans to its surface. So size is important. You see the difference in the moon here in the background in Earth's atmosphere. You can see the atmosphere, and it goes up to a certain height. That's called the rim. It's about 96 kilometers above the surface. The atmosphere of Earth has a density of 760 millimeters of mercury. And this is important. You see, a rock that falls out of space and is attracted to the earth is going to fall down through the earth's gravitational well. Think of it as a funnel. And the rock starts out here and it rolls down the funnel and gets faster and faster and faster. By the time it reaches Earth, if Earth had no atmosphere, the rock would be traveling about, 40,000 kilometers per hour, or 25,000 miles per hour. And it would do tremendous damage to the surface, just like the moon. But the atmosphere slows it down. And so when rocks fall out of the sky, they go much closer, they do much slower, they do much less damage. You had one come through Russia a couple of years ago, right? Did some damage, but nothing like it would do if we didn't have the atmosphere. And you ask, is this important? Well, the big rocks come very infrequently. But it turns out that if you look at the profile of meteors, there are very few big ones. But as you go to smaller ones, the number of them goes up exponentially. So when you get down to the size of a grain of rice, it's a steady drizzle. In fact, 10,000 metric tons of dust settle down on the earth every day because of burned up meteorites in the atmosphere. And most of those meteorites are water, which doesn't make dust. So it's important. So if you had a grain, a meteor the size of 3 grains of rice, it would have the same energy as a bullet from a high-powered rifle. And there's a steady drizzle of this. So yes, this is very important. If we didn't have the atmosphere we have, we would not be able to live. How about radiation? The sun is the mother of all nuclear reactions. It puts out all the mess and the dangerous emissions of a nuclear bomb. So why are we still here talking? I mean, how are we protected from this? Well, one way is the Earth's magnetic field. And I'm sure you know that it has a magnetic field because you've probably used a compass before. But it's much more important than making a compass work. Much more important than help us find our way around on the surface. You see, it turns out there's a particular principle in physics that a particle with an electrical charge on it is unable to go across a magnetic field line. And this is the reason an electric motor works. You run a current through a wire and it's in a magnetic field and it gets a push and it makes the motor work. Well, the same thing happens in space. We have Earth's magnetic field. We have particles coming from the sun that are charged, and they're unable to go across the magnetic field, and they're deflected. If you could see it, the Earth has what we call a magnetosphere, and it would look like this if you could actually see it. It has a bow shock, and here's the Earth's field, and on the sun side, the pressure from these charged particles pushes the Earth's magnetic field in. On the night side, it drags it out further. But what happens is these energetic charged particles, this radiation, is deflected around the Earth, and so we're protected. There are 2 spots where it can come down. It's called the polar cusp, and that's where the magnetic field lines come out, because even though the particles can't go across a field line, they can go down like beads sliding down a stream. So these energetic particles come into the Earth's atmosphere at this point. Here's a picture taken of it from the space shuttle. And you see these streaks that come in, these super energetic particles come in, they slam into the molecules of the Earth's atmosphere and cause them to fluoresce. We talked about that yesterday. It causes them to emit light. So you can see these streaks where these energetic particles are coming down. Of course, from below, we recognize this as the aurora borealis. So it's one of our shields. There are a number of shields like that. The Earth, sure you've heard about the ozone layer. There's a big flap in the States about using things that are causing problems with the ozone layer. Well, the ozone layer is a particular chemical makeup. The oxygen you breathe has two molecules of oxygen, O2. Ozone is O3. Even though it's oxygen, it has an entirely different chemical properties. It's, for example, it's poison, it'll kill you, but it absorbs ultraviolet radiation. Ultraviolet radiation is the stuff, the good thing it does, it gives you a suntan. It can also give you skin cancer. And there are three types. There are three types of ultraviolet, A, B, and C. A is fairly benign, and the width of these bands show how much comes through the atmosphere. Here's altitude over here, surface of the Earth up to 60 kilometers. And this is the density of the ozone, this yellow line here. And these ribbons indicate the amount of ultraviolet that's coming through. So you see the UVA, which is the least energetic and least dangerous, gets attenuated a little bit. About half of it reaches the surface. That gives you a suntan. UVB is more energetic. It's more dangerous. It'll give you cancer. A little bit of UVB comes through. Not very much, but if you buy good sunglasses, they'll have UVB filters on them. This is the most energetic. It will kill you, but it doesn't make it to the surface. So if you're an engineer and you're given the job of designing a UV filter for the Earth and make the most efficient one, you could not do a better job than this. It lets through what doesn't bother us, and it filters out that which is dangerous to life. Let's look at the temperature of the Earth, which is very important. We saw the other planets were either far too hot or far too cold. There are a number of things that regulate the Earth's temperature, not just its distance from the sun. The amount of cloud cover, the atmospheric composition, atmospheric circulation, the ocean circulation, tilt of the axis, and radioactive decay of the Earth's core, which adds heat to it. So if you look at the atmosphere, you see that it's 21% oxygen, 78% nitrogen, and a little carbon dioxide and some other things. Why so much nitrogen? Well, in one of the early launches in America of astronauts, they used a pure oxygen atmosphere in the cabin. A fire broke out while it was sitting on the launch pad, and immediately the whole cabin just exploded. And I don't know if you've ever done this in here, but we used to do an experiment where you take a match, light the match, blow it out, and it's still glowing a little bit, and you drop it into a test tube full of oxygen, and it literally just explodes. So 100% oxygen atmosphere might sound like a good idea, but everything that can oxidize would explode. Trees wouldn't rot, they would explode into flames. So everything that could burn would burn up. Nitrogen is benign. It will not combine with things. It's called an inert gas. And there's so much nitrogen that it slows down the oxygen. So we can have a fire, but things don't explode out of control. It's just the right amount of the mix that we need. Let's look at water. Water has some very unique properties that you know about, but maybe didn't think about it in this way. There was an American naval officer in the 1800s, Matthew Fontaine Murray. And the story goes that he was ill and he was bedridden at one time, and his grandson was reading him the Bible. And he read him this passage from Psalms chapter 8, where it talks about the paths in the sea. And it's reported that Matthew Maury stopped him and told him to read that again. Paths in the sea. So he said, well, if God says there are paths in the sea, they're there, and I'm going to find them. So he spent the rest of his life exploring the oceans. And this is what he found. We know now today that there are a lot of ocean currents. Maybe one of the most famous ones is the Gulf Stream. It comes out of the Gulf of Mexico, carries warm water across to England, where it hardly ever snows, even though it's as far north as Maine in the United States. Goes on up to Sweden. I was in Sweden one time, and it was warmer than it was back home in Alabama because of the Gulf Stream. People didn't know about that then, so our main trade partner back then was England. And ships would come from England, and they would sail, and they would get to a certain point, and it was like they ran into a wall. They couldn't go anywhere. And they would sail for a week or so, and finally they would break through. It cost a lot of money. And Matthew Maury found this out, and he found out this Gulf Stream's only about 60 miles wide, so they realized what it was, and they simply went across it, came out the other side, and it saved tens of millions of dollars. Just a tremendous improvement. And the U.S. Congress decided that they would award Matthew Maury with a cash prize for this great discovery. But sometimes things never change. They changed their mind and decided to vote themselves a raise instead. So Matthew Maury found this because of one little sentence in the Scriptures. It's one of those places where we see the mind of the Creator shining through his language as he strives to save the souls of men. He also found the air currents into another passage. So Matthew Maury, because he took the Bible as true, became what he's called now the father of modern navigation, pathfinder of the seas, mapped the ocean currents, mapped the air currents. At the U.S. Naval Academy, there is a monument to him. This one's in his home state of Virginia, but the engineering building there is named after him. So it's a man that took one little place in the Bible where God's wisdom shines through, took it as word, and found something very interesting. Water is a very unique material. When it freezes, it floats. Very few things do this. Very, very few things do this. And of course you know this, but you might not realize how important this is to you, especially here in St. Petersburg next to the sea. You see, water floats, and as it gets colder, water gets more dense, and it sinks. So the cold water sinks to the bottoms of the oceans, but just before it freezes, at about 4 degrees centigrade, it begins to expand. And expands 10%, and so that when it becomes ice, it's less dense than the water around it, and it floats. Ice floats. Big announcement. But what's the importance of that? Well, I want you to think about it. Because ice floats, every summer, when the sun comes up further to the north, it's exposed to the sun's heat, and the ice melts. At the North Pole and South Pole, it breaks off and floats down to temperate zones as icebergs where it melts. Suppose that it didn't float. Suppose that ice, as it got colder, continued to get more dense like almost everything else does. Then it would sink, the ice would, to the bottom of the ocean. And it would be there forever shielded from the sun. So the next winter, more ice would freeze and it would sink. And the next winter, more ice would freeze and it would sink. Until the whole earth, all the oceans, would be solid ice. Except maybe a little puddles in the summertime. We would have a dry planet, just as uninhabitable as a desert. But because ice floats, it breaks up and floats south and melts, and the ice caps stay a controlled size. Just happens to be the right thing. Another thing you might not have thought about is the moon and what it does. We know that the tilt of the earth causes us to have seasons. Very important here, I think. But it's interesting that the tilt of the earth is stabilized by the moon. The moon is just the right mass and at just the right distance to make the earth stay in its particular tilt. If it weren't for the tilt and its strength that changed, then places like St. Petersburg might not be habitable. Just ice. So, what have we learned? Well, from what we see in space, what we see from physics, the things that we've learned do not conflict with what we see in Revelation. In fact, the more we learn of the solar system, the more we can appreciate just how special the transformation was that Earth went through as God prepared it for life. Secondly, Genesis records the special treatment of Earth, but no other planet. You know, this may be the fact of the matter. There may be no other Earth anywhere, but there is no other Earth in our solar system for sure. The Bible, I believe, was written for mankind on Earth. And whether or not there's another Earth out there somewhere in far distant space is irrelevant to us. The Bible doesn't say there is or there isn't. But it implies that Earth is very special. And what we see when we look at the other planets that we know about, it is very, very special, if not unique. Earth has literally been tuned for life. And thirdly, regardless of one's worldview, whether you believe in God or whether you're an atheist, you have to admit, and it's quite obvious, that something very different has gone on this planet than any other planet that we know about. It's entirely different. Life, as we know it, could not exist anywhere else that we know about. So the scientific observations that we see, we live on a very special and possibly a unique planet. I introduced you to Wernher von Braun the other day. He was a scientist that came to the United States after World War II. And he is the scientist who NASA was built around. And he had some interesting observations about Christianity. And he said one cannot be exposed to the law and order of the universe without concluding that there must be a divine intent behind it all. And I think that's true as you look at how special Earth is compared to everything else. And I think the most striking result after 60 years of space exploration is the unavoidable realization that the Earth is very special. And in a sense, it is an oasis, a garden in which God planted life. By the way, that's one of my granddaughters. So, Sunday, we will talk about the resurrection and the effects of the resurrection. So, thank you for coming tonight.
Спасибо большое, доктор Стоун. А у нас есть время для вопросов и ответов. Большая просьба задавайте ваши вопросы по теме и задавайте их по-русски, даже если вы говорите по-английски. И для этого используйте микрофон. Ну и постарайтесь сформулировать ваши вопросы как можно точнее и проще. Спасибо. Если у вас есть вопросы, вы можете просто поднять руку. Но по-английски. Да, Сереж, нужны наушники.
My question is just, there are layers in the atmosphere. Are there any layers on other planets where the materials have an explanation for how there are layers in the atmosphere?
Okay, on Earth, the layer closest to the ground is a mixed layer because of winds. Above that, there's separations, so you get a stratification of molecules depending on their density. So that's the situation on Earth. On Venus, you have these tremendous winds which will keep it all stirred up. So I wouldn't expect that you would have the layers there. And on Mars, which is the other planet that has an atmosphere, it's very, very thin. It's like, well, as I said, it's like 35 kilometers altitude. So. And Mars also has a lot of wind. So I would not expect that the atmospheres would be the same as Earth's. Yes, big stars of those.
Я вот пришла вот к какому-то выводу, потому что Солнечная система – это система, которая существует свои законы. Значит, если Господь создал Землю, значит, Он параллельно должен создавать вот всю Солнечную систему.
You mean all the planets should be like Earth?
Нет, потому что вы сами говорите, что именно для Земли усмотрено место, которое для Земли усмотрена вот эта орбита, в которой жизнь может развиваться. Но мы знаем, что на Землю и влияют все остальные планеты Солнечной системы. Также та же Луна, вы сами говорили, и все остальные, та же Венера, которая Солнце. Это получается, что Господь создавал, ну как, в один день, там, ну, потому что для Господа это не один день. Значит, всю Солнечную систему должен был создавать.
So it turns out that the Lord created the whole solar system, not just the Earth.
Oh, of course. And in a sense, it's necessary because, for example, Jupiter has a huge gravitational field, and it pulls a lot of junk that would hit Earth otherwise. So Earth is shielded from a lot of things, rocks and stuff, by Jupiter. So the whole system is in balance.
Значит, ни одну планету, ни одну Землю создал. Нет, я говорю, получается тогда...
Нет,
по две, значит,
остальные планеты на четвертый день, а Земля в первый. Вот это мой вопрос.
So probably the main question is, according to the Bible in Genesis, the earth was created in the first day, and on the turns out that first there was just Earth and nothing else, and then other planets appeared.
I believe that the Bible is written in a phenomenological language.
То в Библии написано так называемым феноменологическим языком.
Let me explain what I mean.
Я сейчас объясню, что
We know today that the earth revolves around the sun.
мы знаем, что Земля вращается вокруг Солнца, да?
But what do we say when the sun in the morning? What does the sun do?
Вот что
It
мы
rises.
говорим о Солнце утром, да, что оно делает? Оно
In the
встает,
evening it sets.
утром садится.
And we know that's not what's happening, but that's what it looks
На
like.
самом деле это не так, но
So
выглядит это так.
that's phenomenological language. So
Феноменологический язык.
Genesis is written not as a scientific explanation
Написано не как научное объяснение,
from the perspective of God, but it's written from the perspective of men on earth.
а написано эта книга с точки зрения человека на Земле.
And so the fact that the other planets are mentioned later doesn't necessarily.
Упоминаются позднее, чем Земля.
Some people think that it says that there was a cloud initially.
Некоторые люди считают вообще, что вроде как говорится,
So,
что
so some people think that on the fourth day the cloud dissipated and these other objects came into view.
и поэтому в четвертый день эта мгла рассеялась, и эти другие планеты стали видимы.
But I reserve the right not to know the answer to everything.
Я оставляю за собой право не знать ответы на все вопросы.
Здравствуйте, я хотел бы задать тут такой вопрос. Знаете ли вы о том, что в космосе достаточно много планет, на которых подразумевается рождение жизни? И такие, которые имеют альтернативу, воду и так далее. Вот, допустим, планета Глизе. Знаете ее?
Как называется?
Планета, открытая недавно астроном, называется Глизе.
Recently there was a
Она очень похожа на
discovered by
свою...
astronomers called Gliese, if I'm not mistaken, and it's very Earth-like planet. And there are some Earth-like planets in the universe supposedly, which may have the conditions like on Earth and may have life in some forms. What do you know about it? What do you think about it?
Well, first let's speak of it in terms of Genesis, what Genesis tells. Genesis is written
Что нам говорится в книге Бытия, если с этой точки зрения?
It's written for mankind on the earth.
Эта книга писалась для человечества на земле.
And further, it's written for a very specific purpose, for the salvation of mankind.
Для конкретной задачи, для спасения человечества.
So logically, if God decided to make other earths and other people somewhere else in the universe, it doesn't concern us.
Это вопрос, как бы, он не влияет на нашу славу.
Now, on the other hand, I can tell you that I don't know about this particular one, but there are a few thousand planets known now. Most of them are Jupiter-like, big balls of gas.
Большинство из этих планет похожи на Юпитер, такие огромные газовые.
A planet in that context like Venus would be considered Earth-like. So it doesn't mean you're looking at oceans and islands.
Венера, такие как Венера, уже считаются похожими на Землю. То есть, то, что планета похожа на Землю, еще не означает, что на ней может быть жизнь.
That,
Я ответил как-то на
Немножко, потому что я считаю, что отсюда выделили вода на этой поверхности, которые говорят, что при вода и прошли воду, вот о чем.
Вот нам
То есть,
вы сказали, да?
да, как-то планируют или делают запас.
On that planet that he mentioned, there were
Maybe.
Может быть.
It wouldn't conflict with Genesis. Genesis is silent about what God did elsewhere.
Противоречит тексту бытия, текст бытия ума молчит об этих обстоятельствах. Ничего не говорится.
Yes.
Где написано 4 года, 4000 лет назад, а то, что я вам сказал, было открыто 10 лет назад. Это
So,
10 раз.
Genesis was written, what, 3,500 years ago, 4,000 years ago, but the things I'm telling you about now have been discovered about 10 years ago.
That's true, but Genesis is written by the Creator, and it contains information that people didn't know 3,500 years ago.
Творцом и содержит она ту информацию, которую люди знали 4000 лет назад.
For example, nobody knew about ocean currents
Например,
in
никто
1700s.
не знал об океанских течениях.
So, I think Genesis has a particular purpose,
Я думаю, что
and its purpose is not to educate us as to how and why things work. It's to save our souls.
чтобы объяснить конкретно, как и что функционирует на планете, а в том, чтобы спасти нашу душу.
And the message for us of Genesis is that God is the Creator.
И главная мысль книги Бытия для нас заключается в том, что Бог есть Творец.
So it's not a science book, but interestingly, it contains information
Интересно, что
that was not available 3,500 years ago.
информация, которая 3000 лет назад была недоступна для людей. Об этом еще не знали.
Okay, somebody else?
У меня к вам два вопроса. Первый, как НАСА обеспечивала астронавтов в защиту от космического излучения в миссиях Аполлон?
I have two questions. First, how did NASA provide the protection from cosmic rays, from cosmic radiation in Apollo missions?
И второй вопрос, как вы для себя объясняете взаимосвязь влияния гравитации и времени? Чем сильнее гравитация, тем замедляется время.
And secondly, how can you explain the interrelations between gravity and time? So, the stronger the gravity, the slower the time. Thank you.
Yes. The easy question first.
Сначала простой вопрос.
The Apollo missions
Миссия Аполлон
left Earth and went around the moon.
покинула Землю, облетела вокруг.
You remember the magnetosphere I showed you? It's around Earth.
Картинку магнитосферы Земли, которую я вам показывал.
So there are times when the moon is inside of the magnetosphere and therefore would be protected.
Есть моменты, когда Луна находится внутри магнитосферы Земли, поэтому защищена от излучения.
However, there are times when it's outside of that sphere and would not be protected.
Моменты, когда Луна выходит из этой магнитосферы и не защищена.
So it takes a few days for Apollo to go from Earth to the moon.
Для миссии Аполлон полет от Земли до Луны занимает несколько дней.
And solar activity goes in cycles.
Солнечная активность, она циклична.
You might be aware there's an 11-year solar flare cycle. The spots come and go in 11-year
Вы
cycles.
знаете, что есть так называемые 11-летние циклы солнечной активности.
So, for example, every 11 years you have a period of intense activity, a lot of radiation, and then you have a period of minimum activity and very little radiation.
То есть за эти 11 лет сначала идет пик солнечной активности, много большое излучение, потом идет спад и гораздо меньше уровень излучения.
So the Apollo missions measured in days simply picked the minimum activity times, and they took a statistical chance.
В миссии Аполлон просто выбрали вот этот период минимальной солнечной активности и на основе статистики, вот статистическую вероятность использовать.
So if there had been a major flare eruption during one of those missions, chances are the crew would have been lost.
Но если бы во время этой миссии все-таки произошла бы сильная вспышка на Солнце, то вполне вероятно, что отряд миссии был бы потерян.
I think it's kind of interesting. People are talking about going to Mars today.
И интересно, на самом деле, сейчас вот много говорят о полетах людей на Марс.
So a Mars mission is measured in terms of a few years, not a few days.
А миссия на Марс, она уже будет занимать несколько лет, а не несколько дней.
And instead of being most of the trip within the magnetosphere where you're protected, it's out in interplanetary space.
Будет не полет внутри магнитосферы, где будут защищены люди магнитосферы, а уже в открытом космосе.
So this problem is always ignored by the news media.
Но подобные проблемы в средствах массовой информации всегда игнорируются.
Okay, so that take care of, okay, number
Я
two.
ответил, да? Теперь второй вопрос.
You want to talk about the relationship between gravity and
Time.
time.
Отношение, связь гравитации со временем.
This is more difficult.
Это уже потруднее.
In the early 1900s, there was
В начале 20 века
everybody thought that light had to have a medium to travel in, just like sound waves or water waves. There had to be a medium to carry light waves.
считалось, что I'm sorry, I don't hear you well enough. If you could be closer to the
Oh, I'm sorry, of course. Yeah, all the waves that we knew of before that required a medium to travel in.
То есть все волны, которые до этого момента были известны, требовали какой-то среды для распространения.
Yeah, so you have waves on the Baltic that travel in the water. We have
Волны на Балтике
sound waves that travel in the air.
звуковые волны распространяются по воздуху.
And so the idea was there had to be something for light to travel in.
Такая была идея, что и свет должен распространяться через какую-то среду.
So the medium that was hypothesized was called ether.
Физическую такую среду назвали эфиром.
And it was hypothesized that the light traveled in ether.
Гипотеза такая, что свет проходит через эфир.
So in the early 1900s, there was an experiment done. And they reasoned that if there was an ether that the light was traveling in, and the earth travels around the sun, so it's going this direction in spring and summertime, and it's coming back this direction in winter. It would have to travel at a different speed if the ether is moving and it's going into the earth is going into the ether or coming out of the ether. In other words, if you travel, if you are moving toward a sound, the pitch changes. If you move away from the sound, it drops. You know, you've heard a car go by and the horn goes, "Ee-yong." That same kind of thing should happen to light. So the frequency does that, but the speed is observed not to do that. So Michelson and Morey did an experiment, and they determined that the light speed was the same in wintertime as in summertime. So no ether. So we come to Einstein. So he looked at the equations and he realized that if he assumed light always traveled at the same speed, no matter what, it would solve this problem, but in turn,
то тогда проблема решается.
time
Замер,
and mass would have to be relative.
время и масса должны быть относительными.
So those equations have a relationship between
Поэтому
the speed that you travel and time.
должна быть связь между
And so
скоростью и временем.
as you go close to the speed of light, 300,000 kilometers per second,
И по мере приближения к скорости света, то есть 30
As you approach that,
километров в секунду,
the mass increases
масса возрастает,
and time slows down.
а время замедляется.
And it's just a result of the assumption that Einstein made.
А это результат тех предположений, которые высказал.
And that is observed to happen.
И на самом деле это наблюдается на практике.
But if you're asking why it happens, I can't answer that.
Но если вы спрашиваете, почему это происходит, я на этот вопрос не могу ответить.
Дополнение можно? А почему есть такие крупные космические объекты, которые как линза искажают? Есть крупные солнечные объекты, которые как линза искажают солнечный свет, его движение.
There are large cosmic objects which distort sunlight just like lenses, like
True.
lenses.
True.
Почему, спрашиваете? Why is it happening?
Because there is a link between gravitational fields and the speed of light.
Гравитационными полями и скоростью света.
And there are different models for looking at this. In one model, the light is the speed of the light is affected by the magnetic field, not magnetic field, gravitational field.
В одной модели скорость света влияет, на скорость света влияет гравитационное поле.
In another model, it turns out that the light is curved when it approaches a star. We see that, for instance, you can do it even with the sun. Light comes near the sun and it's deflected a little bit.
Что солнечный свет отклоняется, достигая планеты, например, как в случае с Землей, происходит отклонение за счет атмосферы.
So you can look at it as being caused by the force of gravity and the interaction between gravity and light.
То есть может это быть взаимодействие между гравитацией и светом.
Another model is looking at a different coordinate system in which that turns out to be a straight line.
А другая модель, где рассматривается просто другой системе координат, и где свет уже не искривляется, а
This is way out of normal everyday life.
Но это, конечно, очень далеко стоит от нашего опыта повседневной реальности.
Есть вот такой вопрос. Я подумал, что почему еще можно исследовать космос, не только для того, чтобы там найти жизнь, но и, допустим, полезные минералы какие-нибудь, там, золото, серебро. Вот в этом направлении ведутся какие-нибудь работы, и есть ли какие-нибудь результаты этих работ?
Useful minerals or things like gold or silver, stuff like that. So, do you know any activities in that sphere, in that direction?
As it turns out, the cost of going into space is far greater than the value of gold.
Что на самом деле просто стоимость отправки миссии в космос, она гораздо больше, чем стоимость золота.
The cost per pound is tremendous.
То есть стоимость одного килограмма
And just an aside, the good that's come from that is, there were two approaches. Russia built big rockets and launched big circuits.
Есть два подхода. Россия запускала большие ракеты, большие космические станции.
In the U.S., we had smaller rockets and we miniaturized electrical circuits. So now you
С
can,
большими электрическими цепями. Значит, в США у нас был подход более мелкие ракеты запускать с миниатюрными электрическими
so
цепями.
when I first began college, a 64K memory rack was this high, and this wide, and this deep. Now you carry terabytes around in your pocket.
Когда я учился в университете, студентов, 64 килобайта хранилища информации было вот таких вот размеров. А сейчас можно уже терабайты закачивать.
So the point is, everything is tried to make small to reduce the cost of launch.
То есть, в принципе, идет тенденция миниатюризации для того, чтобы
There were-
стоимость запуска.
There were ideas that they would do things on space station that couldn't be done on the ground, like make perfect ball bearings, for example. And it,
What?
ball bearings, that, you know, like in,
Значит, например, была такая же мысль еще, что в космосе можно делать то, чего нельзя делать на Земле. Например, на космической станции идеальные подшипники изготавливают, идеально гладкие.
and there were other things like producing certain chemicals that would be used in medicine.
А также вырабатывать определенные химикаты, которые можно использовать в медицине.
So, but it turns out that all those things, if you put the money into research that it takes to go to space, you can solve the problems on the ground.
На самом деле оказывается, что если те же деньги вложить, за те же деньги, которые идут на вывод космической миссии, там, на орбиту куда-то, за те же деньги эти проблемы можно решить на Земле, не выходя в космос.
So the astronauts go up there and they exercise.
Поэтому астронавты просто летают в космос и там занимаются зарядкой.
Yes.
Есть такое предположение, что если скорость света, двигаться, вернее, со скоростью света на Земле, то будешь присутствовать во всех точках Земли.
There is an assumption that if you travel with the speed of light on Earth, you will be present in all the points on the Earth at the same time.
There are several ways of looking at things, and there are a lot of assumptions.
Есть много разных точек зрения и много предположений.
When you get into quantum mechanics and relativity,
Если подробно заняться квантовой механикой,
there's certain issues that are important.
то есть определенные моменты, там, которые очень важны.
For example, we travel at such speeds in space and such distances that the time contraction becomes important.
Если в космосе лететь с такой скоростью, такие расстояния, что сжатие времени уже становится важным фактором.
But a lot of these things are very, very theoretical and have no experimental basis at this time.
Все вот эти предположения на данный момент они чисто теоретические, не имеют экспериментального подтверждения.
Anybody else?
Есть еще вопрос?
Джерри на все вопросы ответили, да? Ну, теперь все понятно. Ну, хорошо. Everything is clear now, so no questions.
I think they went to sleep.
А может быть, вы засыпаете уже?
So when there are no questions, you think, well, either I did a very good job explaining, or nobody understands nothing.
То есть либо я очень хорошо объясняю, либо никто еще не понимает.
У меня, например, были вопросы, но я послушал те вопросы, которые были заданы, и их уровень, и решил свои вопросы просто припрятать для себя. Может быть, я в частной беседе задам. Спасибо вам огромное. Конечно, прежде всего спасибо нашему дорогому брату Ноби Стоуну за его приезд. Он, конечно, путешествовал сюда дальше всех. Вместе с супругой 9 часовых поясов он пересек для того, чтобы быть здесь и прочитать эти лекции. Поэтому можете представить сейчас, в каком он состоянии. Но, тем не менее, на мой взгляд, он справляется великолепно со своей задачей. Он не понимает, что я сейчас говорю. Он меня всегда потом переспрашивает: интересно, что ты там говорил обо мне? Ну, я потом его веду в курс дела. Ну что ж, как это не печально, но всему в конце концов приходит конец, во всяком случае здесь, вот на этой планете. Когда-нибудь, наверное, настанет такое время, когда нам не нужно будет расставаться, и мы будем всегда вместе. И у нас, наверное, тогда будет возможность получить ответы на любые вопросы. Вот. Ну, а сейчас мы делаем то, что мы сделать в состоянии. Мы очень благодарны и вам за то, что вы пришли, за то, что вы проявили интерес к этой теме. Мне кажется, что в нашей стране интерес к этой теме очень велик, правда же? Я вот вспоминаю себя в годы юности. Для меня эта тема была очень интересна. Сейчас, послушав эти лекции, мне бы хотелось снова вернуться в 10 класс, наконец-таки взяться за физику и учить ее более интенсивно, может быть, не так, как я это делал когда-то. И астрономия в том числе. Но здесь есть и молодые люди, так что не теряйте время за учебники. Интересно, что можно изучать и нашу Вселенную, и одновременно Библию. И эти вещи совсем друг другу не противоречат. В принципе, у нас в этом не было сомнения до этих лекций, но сейчас, после этих лекций, во всяком случае, у меня это убеждение только возросло. Если вы хотите изучать Писание, если вы никогда его не изучали, или вам не с кем его изучать, то вы можете обратиться к нам, как к сотрудникам Центра христианских ресурсов. Я один из них, но здесь есть также Дмитрий Гусаров и другие наши сотрудники здесь, вот Сергей Федосеев, который был все время за камерой, и он обеспечивал всю техническую сторону этого семинара. Сергей Федосеев, Дмитрий Гусаров. И мне хотелось бы также представить вам нашего бессменного переводчика Евгения Разинова. Если вы когда-нибудь осуществляли перевод, хотя бы последовательный, да, то вы знаете, что это такое. Но делать перевод синхронный, это значительно сложнее. Поэтому мы, конечно, благодарим нашего Евгения за его труд.
So Igor, if we could exceed the speed of light, perhaps you could go back to your school days and I could get my dark brown hair back.
Если мы будем в состоянии превысить скорость света, то я, наверное, мог бы вернуться в школу и засесть за учебники физики, а он мог бы вернуться в то время, когда у него волос было побольше, и они были темнее. Я думаю, для всего есть свое время, как написал Екклезиаст. Меня вполне устраивает то время, в котором я сейчас нахожусь. Я думаю, мы вместе можем сделать еще очень много хорошего.